Hi everybody, a very good evening. Let me share my screen. All right. And it's loading. Just give me a second. Okay. Right. I think everybody is able to see the screen fully. I mean, the words clearly. Is it fine?
Yes, sir.
Okay. Right. The phenomenon in which the cells are swelled up and then burst in placed in hypertonic solution is nothing. Basically, we have a hypotonic. When I say hypo and hyper, right? That means we are considering two solutions in which we have high concentrations and low concentration. Okay. So what we understand is when I say hypo, it is lesser. And when I say hyper, it is higher. Right? So if I tell that this particular solution is hyper with respect to this particular solution, we can say hyper or hypo only with respect to comparing two solutions, right? So when I say that this compound is having higher concentration, or other words are saying is that this solution is hypertonic with respect to this one, and this one is going to be hypotonic with respect to this one, because I think lesser concentration can compare to this one. Right, and we know the osmosis always flows from hyper to hypo, or hypo to higher, right? Hypo to hyper will happen, right? So obviously it is going to be osmosis, which is what is happening here, right? Because inside the cell you'll have less concentration, so it will move inside and they'll get energy, eventually burst, and the answer is going to be osmosis. Exosmosis, endosmosis, don't worry about it. Answer is osmosis. Okay, also option A will be the answer. Okay, next. A beaker containing 3 grams of sugar and 100 grams of water. Another beaker contains 1 gram of sugar and 50 grams of water. Both the beaker are placed under bell jar and not attain equilibrium. Okay. Select the correct statements among the assuming dilute solutions. Neglect the mass of water vapors at equilibrium. Okay. 12.5 grams of 12.5 grams of beaker A to beaker B. Okay. Beaker containing 3 grams of sugar and beaker containing 1 gram sugar in 350 grams water. Both the beakers are placed under a bell jar and allowed to attain equilibrium. Okay. So what are we trying to say is that we have a big this thing and we have two solutions inside, right? One is this and one is this, right? Now, obviously, I'm going to have some vapor pressure, right? It is closed, right? Now, the gas will move from this side to this side or this side to this side, depending on which side I have lesser vapor pressure of H2O. Is it now? Right? So now if I say that 3 grams of water and 100 grams, so that is 3 divided by 5, and here it is 1 divided by, 3 divided by 100, which is 0.03, and 1 divided by 50, which is 0.2, right? Which value is higher? This value is higher, right? This concentration is higher. And we know that whenever the concentration of the solute is higher, the vapor pressure will decrease. Right? So can I conclude that this one, which is having a ratio of 0.2, will have lower vapor pressure? This will have lower VP, and this will have higher vapor pressure. Okay. Now what is going to happen? Now from this side to this side, you will see from which side to which side. Say if this is 0.2 and this is 0.3, the molecules, the H2O molecule is going to flow from this side to this side. Because here I have, right? Now here I have lower vapor pressure, right? So from higher, here I have higher vapor pressure. Isn't it? The concentration is lesser here, right? Since the concentration is lesser, so you understand that there will be higher vapor pressure here, right? And since the concentration is here, you will have low vapor pressure, right? So this will have higher vapor pressure and this will have lower vapor pressure. So it is always going to be from high to low. So this is how the transformation would happen, right? So first it is going to be from beaker A, B to beaker A. Where do we have beaker B to beaker A? Beaker B to beaker A, beaker B to beaker A. Right? Is it not? Fine. Now, yes. So now we have to understand that somehow this concentration, if it becomes equal, right, and then it will be fine, right? So now if I transfer 12.5 grams of water from beaker B to beaker A, what is going to happen? We'll see, right? So in the first beaker, okay, in the 12.5 grams from beaker B to beaker A, right? So if this comes out like this, so we have 1 divided by now 12.5, I substitute 12.5 reduced from 50, it is going to become 37.5, right? And in another case, we have 3 divided by 112.5, right? Are these values going to be same? We'll check. So 1 divided by,
yes, sir, they are.
Are they same? Right, let's just put my calculator. 1 divided by 37.5, which is 0.02266, and we have 3 divided by 112.5. Yeah, exactly. They'll be same. Right. So the answer for this question would be answered in option A will be the correct answer.
Sir, I have a doubt.
Yeah.
Sir, in first question, isn't the answer hemolysis?
Hemolysis.
Yes, sir.
What is hemolysis?
Sir.
Yeah, tell me.
Sir, actually, I've referred a book, and it's clearly given that hypotonic solution, the solid flows into the cell swell and burst.
The rupture or destruction of cells. The phenomenon of bursting of cells is what is called as hemolysis. Okay. So yes, that's it. So we can just know it then. This is a memory-based question. The answer would be C, not A. Right. Moving on. Sir, a solution has an osmotic pressure of 0.02 atm. Yeah, tell me.
Sir, can you show the before question?
Yeah.
Sir, here you're telling like lower the concentration of solute, higher the vapor pressure.
Yes.
Okay, sir.
Right. Okay. Yeah. So next this question, the solution has an osmotic pressure of 0 this much, 300 Kelvin's concentration would be. Now direct formula substitution, pi is equal to C into R into D. Right. Now they're telling that pi is 0.0821. No, pi is 0.821. And C value is what we need to find out. R value is 0.0821 is what you will put, and temperature will put it as 300, right? Now this and this will go 10 times, right? So C will be equal to 10 divided by 300 or 1 divided by 30. 1 divided by 30 is 0.0333. C will be the answer. That's it. Done. Next. A pure water boils at 99.725 degrees Celsius in Shimla. If Kb for water is this much, the boiling point of water, boiling point of 0.6 molar solution of urea solution is. And that's very simple, right? Delta Tb is equal to Kb into M. And delta Tb, however, is elevation and boiling point, right? So you will write it as final boiling point minus the initial boiling point, because that only will give you the positive value. Remember that this delta Tf will be exactly opposite of this delta TFI, and TFI minus TFF it will be, right? Remember, you have to get a positive value, right? And that is equal to Kb, which is 0.51 into M, which is 0.69 molar, right? And TBI they have given as, now you should not substitute in degrees Celsius, you have to substitute in terms of Kelvin. So 99.275 plus, sorry, 99.275 plus 273. You have to add and get the answer. Okay, right? Fine, and then you substitute here, and you all that you have to find is find the boiling point of the final solution. That's it. Every data is given to you. Okay.
Sir.
Yeah, tell me.
Sir, why do we have to substitute Kelvin value, sir?
Always Kelvin value. Oh yeah, in this case you have to substitute. You don't have to substitute. Yeah, because anyways the difference is going to be same. Are you able to get what I'm saying? If it was but yes, some multiplication or division, at that time definitely you have to substitute into Kelvin and only substitute it. But in this case it is difference, so it's okay. Right? You can substitute even the Celsius degree values. Right. Next.
Okay, sir. Sir, what was the answer to the previous question?
I'm not sure. We'll calculate and tell maybe. So you get 0.51 into 0.69, right? 0.3519 is what we get. 0.3519 plus 99 point, sorry, plus 99.275 will become 99.6725. Okay, okay. 99.725. That is 100.07, 100.07, 100.08 approximately. B will be the answer.
Okay, sir.
Next. They're telling that these are the K value. These are for the reaction. All these are given to us, right? Now the rate of disappearance of A is, right? Now you see that A is giving A1, A2, A3 up to AN, some NK, everything is given to us, right? So rate of disappearance would be some R of A will be equal to some K into A power some this thing. Is it not? A power N, right? So you all the ratios here are 1:1. This 1 mole of this gives 1 mole of this, 1 mole of this, 1 mole of everything is given, right? So can I say I should have N A's here so that you will be getting N values of A, so A1 to A1, AN, right? So definitely all that you understand is it would be K A power N. No, but that answer is not there. It is A1. Oh, it's the rate constant also becoming okay. A1, 2, K3, K4, K5, K6, K. Okay, these are all the rate constants also. So if I have different rate constants giving different reactions, now the total would be, when I add two reactions, what will happen to the equilibrium constant, rate constant, same thing would happen.
Sir.
Yeah, tell me.
Sir, in parallel kinetics, like we have to add all the rate constants, right?
Yeah, we have to add all the rate constants. Yeah, we have to add all the rate constants. So if we add all the rate
Sir,
constants,
so
like 1 plus
it's
2
n
plus 3
into n plus 1 by 2. No, sir.
yeah, n into
Option
n
C.
plus 1 by 2, option A. Option C will be the answer. Yes, absolutely true. Right. Okay. Right. You have parallel first order reactions in the syllabus for NCR and CBSE also.
No, sir, it's not there.
Okay, don't worry. But anyways, whenever you have this parallel reactions like this, you have to add the rate constants. That's all you need to understand, right? And A will be power 1 only. Okay, first order reaction it is, obviously. I mentioned parallel first order. Okay, right. Moving on. In the reaction BrO3 minus giving whatever, the rate of disappearance of Br2 is related to the rate of disappearance of bromide ion. That is, we want to talk in terms of D of Br2 divided by dt in terms of D of Br minus. Right. Now, we have Br minus to have a 5 here, right? And we have Br2 to have 3 here, right? And for Br minus, I have to put a negative sign, and for Br2, it is a positive sign. That is also there, right? Fine. So what it should be? So if I write dBr2, this 3 will go here, right? So dBr2 in terms of dBr by dt will be 3 by 5, and should be a minus also, minus 3 by 5. That's it. D will be the answer, right? Very simple. Okay. Next. The rate constant of a reaction is this much. Yeah, tell me.
So can you show first one?
Yeah.
Also before this, fifth.
Before this.
Thank you, sir.
Okay. Right. The rate constant is this much, starting with the 10 mole per liter. The rate of the reaction after 10 minutes is. Now they're telling that it is per minute. If you check, now they didn't give you any first order, the second order, nothing they give. Right. Now they're just asking about, they just given this per minute. When I have per time period, per second, or per second or per minute, what will be the rate? Right? What will be the order of the reaction?
First order.
First order reaction. That's it. So remember that mole per liter per second, if they give you for K, it is 0th order, right? Per second, if they give you K, that will be your first order reactions. Okay. Now all I have to do is substitute the equations. Now we have K is equal to 2.303 by K, 2.03 by T into log of O. What are they asking? The rate of the reaction after 10 minutes. So per minute, The concentration change is 0.693. Okay. Fine. Now we'll have this concentration found out. Initial concentration is 10. The final concentration we don't know, right? First, we'll find out this final concentration. Okay. Once we find out this final concentration, then go to this equation. R is equal to K R power 1. Now the concentration will substitute is after 10 minutes, whatever the concentration is substitute, when you got here, that concentration substitute and find the rate. That's it. Very simple. Okay. Right. So you will find this K is given, T is given 10 minutes, right? R naught is also given 10 M, right? Now you'll find the final concentration and use the R is equal to K into R power 1 and R you have to find, K is known and this K is known, that is not going to change and R value becomes your final concentration, final rate. Very simple. Okay. Next. Arrange the following in the decreasing order of reactivity towards SN1 reaction. Now SN1 it's always about tertiary greater than second. Yeah, tell me.
So like what is the answer to the previous question?
We have to calculate now. So it would be you get 2.303. Right. Okay. So you get 2.303 by 0.0693. So what will be the answer then? 2.303. 2.303 divided by 0.0693.
Sir, but 0.0693 is a K value.
That's what. Now, okay. Oh, whatever it is. So, fine. If I rewrite the equation for you. So, this is what we need to do. So, K, which is 0.693. is equal to 2.303 by 10 minutes, 2.303 by T into log of 10 divided by R. This is what we have, right? So if I have to calculate this log of this value, that would be, okay, this is 0.0693. So this will become 0.693 divided by 2.303, 0.3010. Okay, now 0.3010 is equal to log 10 minus log of R, right? So can I now, what will you put this log value of 0.3010? This is going to be 2. Log of 2 values only 0.3010. So I can say that 10 divided by R will be equal to 2. So the final concentration would be nothing but this will come here and this will come here. So this will become 5. Now you go to the equation. R is equal to 0.693 into the final concentration is 5. So you get 0.0693 into 5, 0.3465. Yeah, 0.3465 is C. That'll be the answer. Okay.
Okay, sir.
Right. So now we have to arrange them in the order of SN1 reaction. So we know tertiary is more stable than secondary. Secondary is more stable than in terms of carbocations. Okay. Now you see that this is primary and this is also primary. But this carbon atom is also primary and this carbon atom is tertiary. This is tertiary. Okay. And you see that this carbon atom attached to only one. This carbon atom attached to only one. This carbon atom attached to only one. But you understand that if a bulky group is present nearby, I don't know whether you know rearrangement is possible. Do you know that? Rearrangement in carbocations is possible. I don't know why are they even giving me this question. So if I shift this hydrogen, I'm getting a secondary. If I shift this methyl group, I'm getting a secondary, and here nothing happens. So it should be, or if you check in terms of hyperconjugation, now here I have, at least here I have 1, here I have 2. Okay, let us do in terms of hyperconjugation. Okay, hyperconjugation means you check that this is the positive charge which I'll have if after removing Cl. A hyperconjugation is directly proportional to the number of alpha hydrogens. Right, and more is hyperconjugation, more and more is the stability. Okay, now in this case you see that this one indeed has one hydrogen, right? This has one hydrogen, this carbon atom. Okay, so this one will have, you see that there will be 2 more hydrogen. I mean, for this carbon atom, draw a structure here. We have Cl, we have one CH3, we have one CH3, and we have a H. We are talking about positive charge on this carbon, right? Now, first of this carbon will be stabilized by one particular alpha hydrogen. This is the alpha position. And for the other one, we have This is Cl, and this will be the positive if I remove the Cl, right? Now you see that this one has 1, 2, 3, 3 groups, and already 4 groups, so there is no hydrogen atom here. So I said hyperconjugation will be directly proportional to the number of alpha hydrogens, and more hyperconjugation, more and more stability, right? So S will be the maximum stable. After that, it should be Q because it is at least having 1 alpha hydrogen. Then it should be R, and the least stable or least stable will be least reactive. So P will become, so SQRP. SQRPC is the answer. Right? Next. Okay, ethylene chloride is ethylene chloride. Ethylene chloride is going to be CH2. No, ethylene chloride is CH double bond CH, Cl and Cl. Okay, this is what is ethylene dichloride, ethylene chloride, right? Now you see that Cl is directly attached to the double bond carbon. So these kind of structures are what are called as your vinylic structures.
Sir?
Yeah.
Sir, alkylidine basically means geminal, right?
1 second, wait.
And alkaline is vicinal.
1 second. Alkylidine, methylidine. Oh yeah, then. Yes, what you said is right. So alkylidine, if they give you, right, that should be geminal, right? And if they give you alkaline, right, that is going to be vicinal. Yeah, that is going to be vicinal. Right now they're given ethylidine, so alkylidine it is, so it should be geminal. Where is it? Geminal dihalide.
Sir,
Okay. Yeah, tell me.
sir, in the 8th question, sir, like the previous question, sir, like in R structure, more hyperconjugation is there because there are 3 alpha hydrogens, right?
No. If I look into this is a structure, right? This is your carbon and this is your alpha carbon. This carbon is your alpha
Your
carbon.
voice is breaking.
Is it breaking for everybody?
Yes, sir.
Why is it happening? Only for your class it's happening. Other classes it's not happening. Still it is breaking. Guys,
Sir,
Yes,
it's still
sir.
breaking, sir.
still breaking. Let me join back again. Make me the host. Whoever is made the host.